Hello everyone, welcome to another video on differentiation, and today we are discussing a differentiation of a function with respect to another function. Okay, so till now we have differentiated everything in terms of x. Now we may have to differentiate a function with respect to another function, maybe sine x with respect to cos x, maybe tan x with respect to x cube, maybe sine under root 1 minus x square with respect to x square, something like that. Okay, so we may not have to simply differentiate with respect to x only, because till now whatever we've been doing, we were trying to find dy by dx. Every time we do a sum, the ultimate answer would be dy by dx. Now you may have to differentiate with respect to another function. You will get an idea once I solve a sum. Okay, so I want you to copy this theory first here: differentiation of function with respect to another function. So just to give you an idea, let's say you have two functions, fx and gx. Did you see here? Let me highlight in different color, not red. Okay, so rule, what is the rule, everyone? The rule says if there are two functions fx and gx, then I can say y equals to fx and z equals to gx. Okay, I can give two different names to this function. So I say fx equals to y and gx equals to z, two variables I assign. Then what I have to find ultimately, I have to differentiate fx with respect to gx, isn't it, everyone? So that is basically I need to differentiate y with respect to z. Let me write here y with respect to z. What is the differentiation of y with respect to z? That's dy by dz. Basically I need to find dy by dz, correct? So what will I do is, this is not possible to do directly. Like, you know, in parametric we have two functions. Whenever we have two such functions, we need to do same as parametric functions. What do? We differentiate each one of them with respect to x. So here first we differentiate y with respect to x, dy by dx, and next we differentiate z with respect to x, that is dz by dx. Then ultimately what do? We combine them. And how to combine? My target was dy by dz, so dy by dz will be equals to dy by dx divided by dz by dx. It is as if the dx and the dx gets cancelled and you get the answer. So that will be the differentiation of y divided by differentiation of x, and that would be the answer. Okay, so if we do a sum, I hope you will understand this. This is similar to parametric functions that we have done in the previous classes, correct? Okay, so let us go to the first example. The first example I have for you is differentiate sine x cube with respect to x cube, correct? So here, had it been, okay, suppose if it was differentiate sine x cube, it can simply be differentiate sine x cube. Then you could have directly said let y equals to sine x cube. Then I'll have to find dy by dx, isn't it, everyone? But here I'm not, dy by dx will be d dx like this. Let me show you full sine x cube, then do sine first, then do x cube. That is chain rule, you know it, isn't it? That will be how much? Cos x cube, and dx of x cube is 2x squared, something like this. So the answer will be 2x squared cos x cube. That's dy by dx. Got it, everyone? Yes. But this is not the scenario here. Remember, you don't have to find dy by dx. What are you supposed to find? You have to find, suppose if this is y, by the way, if this is y, then you have to find dy by d of this x cube. You have to find dy by d of x cube. You have to differentiate sine x cube with respect to another function x cube. Okay, so this seems quite complicated here, writing x cube here. So what will I do is, I'll rub this. Let us do the like the theory as mentioned here. I have to say that the I have to say that the first function is y and the second function is z. So let's start, everyone. So let y equals to sine x cube, and let's say z equals to x cube, the second one. Got it? So let's find dy by dx first. What will be dy by dx, everyone? Dy by dx will be, like I've done earlier, d dx of sine x cube. That will be cos x cube into d dx of x cube, chain rule. I hope you remember d dx of x cube is 3x squared cos x cube. Am I correct, everyone? Check this out. So that's the differentiation of the first function. That's the one. Got it? What about the second one now? Let's do the second part. I have to find dz by dx. So that will be d dx of x cube. That will give me 3x squared, correct? So that's dz by dx. So now ultimately let's combine them. How to combine? Dy by dx, dz you have to find. You have to differentiate the first function with respect to the second one. First with respect to the second one. That is basically dy by dz. So dy by dz will be dy by dx divided by dz by dx, whatever you have obtained here. So let's fill it up. 3x square cos x cube, that's dy by dx, and the second one is here 3x square. So cancel it out, and what is the answer, everyone? The answer is cos x cube. So that will be the differentiation of the first function with respect to the second function. Careful examination, check it out, everyone. What did I do? I have assigned two variables to do two different functions and differentiated it accordingly. I suppose this is somewhat similar to parametric functions. It is indeed very important, remember. Okay, here we have the second one. Differentiate x to the power sine inverse x with respect to sine inverse x. So similar concept. How will I start with, everyone? I'll say let y equals to x to the power sine inverse x, let's say the first function, and let's say z equals to sine inverse x, correct? So I'll have to differentiate the first one first. So this looks like a exponential function, isn't it, everyone? There's a variable in the denominator as well as variable in the numerator. So this type of differentiation is called logarithmic differentiation. I'll have to apply log, isn't it? Or else I can use the direct formula. What was the direct formula? Let's start. So differentiating both sides with respect to x, both sides with respect to x. What do I get? Dy by dx equals to ddx of x to the power sine inverse x, isn't it? So after this I get dy by dx ultimately equals to the formula is x to the power sine inverse x into ddx of u log v log u. That means sine inverse x log x, correct? So that's the formula. Now I will write x to the power sine inverse x. Check this out, and let's differentiate this. I'll have to apply product rule. Second, that's log x, into ddx of first, that's sine inverse x, plus first, that's sine inverse x, into ddx of second, that's log x, correct? Okay, I get after that x to the power sine inverse x, and ddx of sine inverse x, what is it, everyone? 1 divided by 1 minus x squared. So I'll have log x divided by under root 1 minus x square, that's the first one, plus sine inverse x divided by x, correct? So that would be the second one. Great. So I suppose that's the okay, let me simplify it a little. Okay, so x to the power sine inverse x, and let's take LCM. What is the LCM, everyone? X under root 1 minus x square is the LCM. I get here x log x, and here I get under root 1 minus x square sine inverse x, correct? So I think that'll be right. Okay, great. Now time to do the z part. So I have suppose z equals to sine inverse x. So differentiating both sides with respect to x. Again, this one also with respect to x, because ultimately I have to find dy by dz. I have to differentiate the first function with respect to the second function. That's y with respect to z. Alright. So dz by dx will become ddx of sine inverse x, and everyone knows what is ddx of sine inverse x. 1 divided by under root 1 minus x square. That was it, isn't it? Check out the formula. Therefore ultimately dz by dy by dz will be dy by dx above and dz by dx below. So that gives me what is the different derivative? X to the power sine inverse x. I can write like x under root 1 minus x square, and inside the bracket I have x log x plus under root 1 minus x square sine inverse x. Okay, divided by 1 divided by under root 1 minus x square, correct? Check this out again. I'll show you how. I'll highlight it. This was the derivative. This was the derivative of dy with respect to x, isn't it, everyone? And this was the derivative of z with respect to x. So I've just put it here, up, and numerator and the denominator. So let's cancel the factors. This and this gets cancelled. So the ultimate answer is x to the power sine inverse x divided by x log x plus under root 1 minus x square sine inverse x. So you can keep it like this. So that's the perfect answer. So did you understand? It looks quite complicated, but it's absolutely correct. So that's how we do. So as you all can see inside some sums that we do later, like this one was differentiation of one function with respect to another function. Here we also have logarithmic differentiation inside it. So the more you practice, the more you will brush your skill and you'll become perfect in differentiation. I would suggest you practice many sums, find some more sums of your own and practice. If you have a book, you can solve some examples from your book. Okay, so that will help you brush up your skills. Okay, so the more you understand differentiation, the more helpful it will become to understand further topics to come. Remember, differentiation is a long chapter. There's a lot of things we have to do here. Also, after completing differentiation, we need to do a chapter called integration, which will be just the reverse of differentiation. It's called antiderivative. Okay, the third sum you have to differentiate. By the way, I forgot, so like it will be differentiate. Let me move this a little. Differentiate tan inverse under root 1 plus x square minus 1 by x with respect to tan inverse x. So the same logic, what will I do first? Let y equals to tan inverse under root 1 plus x square minus 1 divided by x, and the other side z equals to tan inverse x. So I have to differentiate both with respect to x and then combine them. Got it? So let's start. So what will be dy by dx? But before doing dy by dx, let's simplify this. I suppose you have already seen this somewhere. We have solved this sum earlier in differentiation of inverse trigonometric function as well. So what was the substitution? Let x equals to tan theta. When I do that, I'll get theta equals to tan inverse x. Check this out. I'll get y equals to tan inverse under root 1 plus tan square theta minus 1 divided by tan theta. I'm trying to simplify, not differentiate. Got it? This is how we start the sum, isn't it? Y equals to tan inverse. This becomes sec square theta and under root minus 1 divided by tan theta, if you remember this, because the formula identity says 1 plus tan square theta is sec square theta. Root and the square gets cancelled. You get y equals to tan inverse sec theta minus 1 divided by tan theta. Time to simplify. Why? Because I would want this thing, check this out, I would want this thing to become tan, then only it will self adjust. Got it? So ultimately y will be equals to tan inverse. Let's simplify. I'll get 1 by cos theta minus 1 divided by sin theta by cos theta. Okay, time to take LCM. Y equals to tan inverse. I have a cos theta as LCM. It will be 1 minus cos theta in the numerator and sin theta by cos theta. Correct? That's what I have. Then cos theta gets cancelled. Y will be ultimately equals to tan inverse 1 minus cos theta divided by sin theta. If you know the formula, what are the formulas? The formula is, let me write it just here. 1 minus cos theta in trigonometry divided by 2 is 2 sin square theta by 2 in half angle formula, and sin theta is 2 sin theta by 2 cos theta by 2. Check out the formula from class 11. That's the half angle formula. Replace. So I'll get tan inverse 1 minus cos theta means, sorry, I think I'll have to simplify this. There shouldn't be a 2 here, or I can do like this. If there is a 2 here, then I have to cut this 2. If this 2 moves here, then this 2, it is just movable. This 2 will move here, just simple. Okay, so it'll be 2 sin square theta by 2, because I just need a replacement for this, so 2 moves there, and here 2 sin theta by 2 cos theta by 2. Correct? 2 and 2 gets cancelled. One of the sign gets cancelled. I land in y equals to tan inverse sin theta by 2 by cos theta by 2, and that's how much, everyone? Y equals to tan inverse tan theta by 2, and the answer is y equals to theta by 2. Not the answer, I say it's a simplified form. Okay, so what will be dy by sorry, now time to replace. Y will be, theta means tan inverse x, isn't it, everyone? Check this out. Yes, yeah, theta means tan inverse x, so y will be half tan inverse x. So dy by dx, now I have to differentiate, will be half into what is ddx of tan inverse x? 1 by 1 plus x square. I'm doing it directly. So 1 by 2 1 plus x square is the derivative. So the first part is this one. Correct? Let's do the second one. What was the second one? We've left it far here. Okay, z equals to tan inverse x. So dz by dx will be ddx of tan inverse x. Oh, that's quite simple, everyone. What is the answer? 1 divided by 1 plus x square. That's the z part. Okay, so check this out. It's too far. Okay, this is the z part, and here down here this is the x part, y part. So let's combine them. I'll combine somewhere here. So what will be the answer? Therefore dy by dz, because I have to differentiate y with respect to z, will be dy by dx divided by dz by dx, and that would give me how much? Dy by dx was half, and below 1 plus x squared, and here 1 by 1 plus x squared. Check this out. Is it correct? Where is it? Yes, absolutely. So cancel, and the answer is half. So the differentiation of this function, differentiating first with respect to second, we will get half as the answer. Is that clear?